Okay. So what I'm going to do here, this is going to be the exam 1 review for Math 160, college algebra. So I'm going to, show you how to do these problems on the review sheet. So yeah, just to, before we get started, I just want to make a comment that, there could be problems that I don't ask here that could be on the test, but that doesn't mean I didn't cover them. It just means that they're not on the sheet. But they could be fair game for the exam. But I think if you know how to do the most of these problems on this sheet, I think you'll be fine. I really do. So let's look at them. All right. So the first equation is -2 times 5 minus 3x plus 8 equals 4 plus 5x. All right, well, this is a linear equation. This is linear because the variable x has an exponent of 1. So that means it's linear. So, all right, you just want to distribute, combine like terms, and get the x by itself. That's as straightforward as it gets, right? So distribute the -2, you get -7, or -10, I mean, sorry, times -3x is positive 6x, plus 8 equals 4 plus 5x. All right, combine terms on the left, so -10 plus 8 is -2, plus 6x equals 4 plus 5x. All right. Now you want to get the x's on one side and the numbers on the other, so subtract 5x from both sides, and 2 to both sides. So on the left side, you're going to get what? You're going to get, so 6x minus 5x is x equals 4 plus 2 is 6. Now, again, you could check this solution in your calculator, right, by storing it in for x. So x, store x, type in the left side, and then type in the right side, hit enter. You should get the same value for both sides, right? So -2 parenthesis 5 minus 3x, close parenthesis, plus 8, hit enter, I get 34, and then if I hit 4 plus 5x and hit enter, I also get 34. So that checks out. So my solution is, my solution set is 6. All right, letter B. X times 1 minus x equals 6. So whenever you're solving an equation, you got to distribute, and just like, you got to distribute and combine like terms. You want to get all the terms combined and then go from there. So let's distribute the x here. So I get x minus x squared equals 6. So now because I have x squared here, right, I know that I'm dealing with a quadratic, right? So because I'm dealing with a quadratic, I want to put it in standard form, right? So that means I want to set the right side equal to 0 by subtracting 6. Right? I want to subtract 6 from both sides. So I'm going to get, let me get rid of that. So I'm going to have negative x squared plus x minus 6 equals 0. All right? I just rearranged this in descending order. I put it in standard form. Now it's not quite in standard form, right? Because this is a negative x squared. I want positive x squared. So to do that, I'm going to multiply both sides by -1, right? Because I want to make sure this is in standard form. I don't want the leading term to be negative. So when I do that, I'm going to get x squared minus x plus 6 equals 0. That's what I have now. Right? So now this is a quadratic in standard form. So how do you solve it? Well, you could factor it. You can do completing the square or the quadratic formula. Now, if you could factor it, you should always try and factor it. So how do you factor a quadratic? Well, you look at the AC method. You could use the AC method one of two ways. You could do it with grouping, or you could do it by trial and error. But since the leading coefficient here is 1, I would, so you have 1x squared. I would say that trial and error is the best way here because it's more efficient that way. That's just me. So you just look at all the factors of 6, right? 1 times 6 and 2 times 3. So this means I have 2 factors, and this means I have 2 factors. So I could either have what? So x, 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 right? So this means I could have 1 here, 6 here, or this means I could have 2 here and 3 here. I just want to pick the combination that gives me negative x in the middle, right? So this first combination isn't going to work because that would give me 6x and 1x. That would give me 7x. So that one's not going to work. Let me look at the second combination, right? So this would be 3x. That would be 2x. I could get negative x from there, right? If I did the outside inside part, right? I'm doing the FOIL process to check what my signs are going to be. So x times 3x, I'm sorry, x times 3 is 3x, right? And then 2 times x is 2x. How do I get them to be negative x? How do I get that? Well, that would mean that the 3x would be negative and the 2x would be positive, right? So that means that the x and 3 is going to be negative, and the 2 and the x is going to be positive, right? And if you do 2 times negative 3, well, I don't get negative 6, do I? I don't get negative 6. So what does that mean? What does that mean? It means that this doesn't factor. So this, I was pretty close. This means this doesn't work. That's not going to work. And this combination is going to work either, because if I do 2 times negative 3, I don't get negative. I have positive 6 here. So this means this doesn't work either. That doesn't work either. I'm close. Like, the middle term gives me negative x, but the last term doesn't give me negative x. I have positive 6. This gives me negative 6. So this doesn't factor. So it doesn't factor, which means I have to use either completing the square or quadratic formula. Either one. I am going to do completing the square because I think you guys need more practice with that. That's my opinion. So because I know that this doesn't factor, I know that since I know that, my solutions here are going to be complex solutions. They're going to be imaginary complex numbers because I know it doesn't factor. So if I do completing the square, what do? So that means I subtract, I'm going to bring the c term over, right? So I have x squared minus x equals negative 6. Right? Now I do completing the square, right? So I identify my b coefficient, which here is negative 1, right? So I'm going to take negative 1, divide it by 2, and square it. So that gives me 1 over 4. I'm going to take that, I'm going to add it to both sides of my equation. So I have x squared minus x plus 1/4 equals negative 6 plus 1/4. Okay. My left side is still the same. My right side, so negative 6 plus 1/4, you just add that together. I'm using my calculator. That gives me negative 5.75, which as a fraction is negative 23 over 4. Negative 23 over 4. Okay, now what I could do here, since I have a fraction here, and we don't typically like fractions. So remember, when we did completing the square, this becomes a perfect square quadratic, which means its factors are the same. So I don't want to deal with fractions, so I could just multiply both sides of the equation by 4. So when I do that, I get 4x squared minus 4x plus 1 equals negative 23. I don't have to do that, but it's better to work with real good numbers than fractions. Now, again, this is still a perfect square quadratic. Just like this one was. This is still a perfect square. Quadratic. It's still a perfect square quadratic. So that means that when this does factor, and the factors are going to be identical. So, you could factor this with the AC method by trial and error, right? So the leading coefficient here is 4. The C value here is 1. So the factors of 4 are 1 and 4, 2 and 2. The factors of 1 and 1 and 1. Now I know, since that this is a perfect square, I know the factors are going to be the same. So I know that these two and these two are going to be the ones I need. I know that, because they both have to be the same. So this is the value. This is the coefficient for the x term. So that's going to be 2x and 2x. And the 1 is going to be the value for the C term. That's going to be 1 and 1. All right. Now to get the signs, they're both going to be positive or they're both going to be negative. All right. I have a negative 4x. So 2x times 1 and 2x times 1. When you add them together, they got to be negative 4x. So that means they both have to be negative. That would be negative 2x, and that would be negative 2x, which adds together to be negative 4x. So those are my factors. And you know that because negative 1 times negative 1 is positive 1. All right, just go through the FOIL process here. You go through that in your head to verify that this is the factors. So now, because these are the same, I could write this as 2x minus 1 quantity squared equals negative 23. From here, it's pretty straightforward. Just take the square root of both sides. So you're going to get plus or minus the square root of negative 23. Now I said earlier that since the original quadratic didn't factor, I know that I'm going to have complex numbers. So I can factor an I out of here. I'm going to get plus or minus I square root of 23. 23 doesn't reduce because that's a prime number. So the right side becomes this. The left side is 2x minus 1. So I could add 1 to both sides. So I'll have 2x equals 1 plus or minus I root 23, and then divide both sides by 2. X equals 1 plus or minus I root 23 all over 2. Which, if you wrote that as your solution set, You could write them plus or minus, or you could write them separately. You could write this as 1 plus I root 23 over 2, comma, 1 minus I root 23 all over 2. Those are my solutions. And again, if you want to check those in your calculator, so if you want to check these in your calculator for the original equation, which was up here, you could just, remember to put your since these are imaginary numbers, you want to put your calculator in complex number mode. So to do that, you go to mode, you go down to A plus BI. So now, second quit. So let me store this one in. So fraction 1 plus second. Remember the I button is right here above the decimal point. I square root 23. Oop, pressed the wrong button, sorry. Square root 23. That's in the numerator, divided by 2. I'm going to store that in for x. Hit enter. This just writes it in, in standard form, A plus BI. And then you're going to type in the left side, hit enter, and hope you get 6. So x times the quantity 1 minus x. I get 6. So that means that this one works, and you could also check the other one. That'll work as well. But yeah, that's how you do it. So this one was a little lengthy, but all I'm doing here is saying, all right, so I should check to see if it factors, and since it didn't factor, I have to use either completing the square or the quadratic formula. I showed it completing the square. Yeah. Because I feel like that's more experience for you. Alright, let's go on. Letter C. X minus 1. 2x plus 3 equals 3. So again, distribute it all out. This is a binomial times binomial, so you're going to FOIL it. Okay, FOIL it out. X times 2x is 2x squared. X times 3 is plus 3x. Negative 1 times 2x is negative 2x. Negative 1 times 3 is negative 3 equals 3. Combine terms. 2x squared plus 3x minus 2x is plus x minus 3 equals 3. Put it in standard form. This is a quadratic because the highest power is squared. So this is a quadratic, so put it in standard form. Bring the 3 over. So you're going to have 2x squared plus x, subtract 3, you're going to get negative 6 equals 0. So you have 2x squared plus x minus 6 equals 0. So this is my quadratic in standard form. Again, if you could factor it, factor it. Try and see if you could factor it. So I'm going to bring it over here and let me factor it. So the leading coefficient here is 2. The C value is 6. So my factors of 2 are 1 times 2. My factors of 6 are 1 times 6 or 2 times 3. Now because my leading coefficient here wasn't 1, I have to, I'm going to have 2 cases of each combination. So my first combination with these first 2 pairs is going to be, I'm going to have 2 combinations for that, right? And then for these 2 pairs, I'm going to have 2 more combinations. These are all the possible combinations of this quadratic. So these are the values for the x term, the x squared term. So this is x and 2x, right? X, 2x, x, 2x. Now I'm going to have 1 and 6 for the first one, and then 6 and 1. I'm going to swap them because my leading coefficient is 2. If my leading coefficient was 1, I don't have to do this swapping thing because it wouldn't make a difference. Now my next 2 are going to be, all right, x and 2x. That's the same for all of them. And then for 2 and 3, it's going to be 2 and 3, and then 3 or 2. All right, now I just need to figure out the signs for the middle term and the last term. I'm just going to make sure the signs check out for when I do the FOIL process. So I got to find, so my correct factors are going to be one of these 4 possibilities. It's going to be either the first, second, third, or fourth one. I just got to find which ones are going to work, if one of them does work. So when I go through FOIL, right, I'm doing the outside, inside part here, right, and then I want to do the last part to make sure I get the negative 6. So the outside part is 6x, right? That right there is 6x. The inside part is 2x. I want them to combine to be positive x, right? I want to add these 2 to get x. Can I get x by adding these 2 or subtracting them? No. That's not going to work. So I know the first one doesn't work. Let's look at the second one. The outside here, that's x. The inside here, that's 12x. Are they going to add to give me x? No. You won't be able to add them in any way to get x. That's not going to work either. So I know the first 2 don't work. Let me try the next 2. So the outside here, right, that's 3x. The inside, that's 4x. I want them to add together to get x. Can I add them to get x in some way? I could, yes, I can. Yeah, in order for these to add to be x, right? In order for these to combine to be x, this needs to be 4x, right? Positive 4x and negative 3x, right? Do the math. Negative 3x plus 4x is positive x. And that's what I have, positive x. So this means the 3x should be negative. So x times 3, that should be negative. And this means that should be positive. The 2 times the 2x should be positive. The last thing I need to check is the last term in the FOIL process. 2 times negative 3, does that give me negative 6? It does. So these are my factors. So those are my factors. So I know that this is the AC method by trial and error. Just listing all the possibilities. So I know that my factors are going to be x plus 2 times 2x minus 3 equals 0. Again, this is a review of what we did, so if you're still confused by this, you could do the AC method by grouping if you want. This is just trial and error. But you could do it by grouping. Either one works just fine. This is the way I prefer to do it, so that's the way I just think it's more straightforward. That's just me. So x plus 2, so I'm going to set each factor. Since this factors, I could just set each factor equal to 0. Which means the first one's negative 2. 2x equals 3, which means x equals 3 halves, which means my solution set is going to be negative 2 comma 3 over 2. And again, you could check your solutions by your calculator, but that's it. I'm not saying you have to show this all, you don't have to show all this work completely. I'm just showing you the process of trying to get the factors for what you need. letter D, 2x plus 3 equals 4x squared. All right, the highest power I see is a squared, so I know this is quadratic. Let me put it in standard form. Let me bring these guys over here. So I'm going to have 4x squared minus 2x minus 3 equals 0. Since it's a quadratic, I want to see if I can factor it. I know factoring these things by trial and error could be confusing to some of you, but so again, leading coefficient here is 4. So my factors of 4 are 1 and 4, or 2 and 2. My factors of 3 are 1 and 3. So because my leading coefficient isn't 1, I'm going to have to flip each combination. So here's a combination, and here's a combination. So my first combination gives me 2 possibilities. My second combination gives me 2 more possibilities. Okay. So 1 and 4, that's for the x squared term. That's going to be x and 4x. X and 4x. Right? 1 and 3, and swap them. 3 and 1. Okay, now I go to the next combination. This is going to be 2x and 2x. 2x and 2x. 1 and 3. And swap them, 3 and 1. Now, I just got to do the same thing I did in the previous one. I got to look and see which outside-inside combination gives me negative 2x, if it exists. Okay, let's go do each one. So this is going to be x times 3, and this is going to be 1 times 4x. All right? X times 3, that's 3x. 1 times 4, that's 4x. Do they add together to give me negative 2x? No. That's not going to work. That's no good. What about the next one? That's going to be x. 3 times 4x is 12x. Would I be able to get 2x from, or negative 2x from that combination? Adding them together? No. X plus 12x is 13x, or, you know, x minus 12x is negative 11x. I'm never going to get 2x from that. That's not going to work. Let me try these two. Okay. So this is going to be 2x times 3 and 1 times 2x. So that's going to be 6x and 2x. Can I add those together to get 2x or negative 2x? I don't know about that. That's going to give me 8x or 4x, but never negative 2x. So that's not going to work either. And guess what? If you notice here, I mean, you could go through it again like this, you know, 2x, 6x, right? Oops, sorry. Two x and 6x, that's the same combination as the previous combination. Right, here's the 2 and the 3, here's the 2 and the 3, here's the 2x and the 1, here's the 2x and the 1. This is the same combination. So this doesn't work either. It's the same combination, they're just, you know, the products are flipped, but that's still the same thing. 5 times 2 is the same thing as 2 times 5. So none of these combinations work for this. So this doesn't factor. Which means I'm going to have to do what? That doesn't factor, which means I'm going to have to use either completing the square or the quadratic formula. Either one works just fine. So, I'll do the quadratic formula this time. This means A equals 4, B equals -2, C equals -3. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. -b, so b is already -2, so that's negative of -2 is +2, plus or minus the square root of b squared is going to be -2 squared, which is 4 minus 4 times a, which is 4, c, which is -3, all over 2 times 4, right? So go through that. 2 plus or minus the square root of, so 4 minus, so just do this computation right here. Compute the discriminant, right? That's what we're doing. Right. All right. 4. So -4 times 4 times -3 is 48. So I'm going to have 4 plus 48 all over 8. Wait a minute, something's fishy here. If this doesn't factor, then this should be positive. This should be negative, not positive. Maybe it does factor. It does factor. Huh. Why doesn't it? Does factor now. Yeah, it does factor, but the factors are going to be ugly. So yeah, I mean it doesn't. Let's just keep going with this. I mean there's nothing wrong here. It's just these didn't work out. So let's just keep going. Let's just keep going. There's nothing wrong here. 4 plus 48 is 52 all over 8. So now the square root of 52. So I want to see if I could simplify the square root of 52. I want to factor out a perfect square out of there if I can. So 52 divided by 4 is 13, so that means the square root of 4 times the square root of 13, right? And the square root of 4 is 2. So the square root of 52 reduces to 2 root 13. Alright, so let me come down here. So I'm going to have 2 plus or minus 2 root 13 all over 8. I'm sorry about pausing there for a minute. I was just the solutions to this are going to be some weird numbers, but that's why it doesn't factor per se. Okay, so if I go here, I could reduce this down, right? The 2 goes in the 8, right? So this is going to be 1/4 plus or minus 1/4 over with root 13 here. So I could just break this up and write this as 2 over 8 plus or minus 2 root 13 over 8. All right, 2/8 is 1/4 plus or minus root 13 over 4, because the 2 and the 8 reduce to 1/4. So those are my solutions. So my solution set is 1/4 plus root 13 over 4 and 1/4 minus root 13 over 4. So again, you could check your calculator. You could check the solutions with your calculator. 1 plus root 13 divided by 4. Store that in the x. And then you could do it in the original equation. You could do it in the second equation. Either one's fine. If you just type it in the second equation, 4x squared minus 2x minus 3 gives me 0. So I know that this is a solution, and you could check the other one too. Sorry about pausing there for a second. I threw myself off a little bit, because the fact that the discriminant was positive doesn't mean it factors. It just means I have 2 real solutions, which I do. I have 2 real solutions. It's just that the solutions aren't factorable. They're going to be ugly solutions. Sorry about that. But, you know, just use the quadratic formula. Or you could do completing the square. You don't want to work. Alright. Letter E. Alright, that was D. Let's do letter E. So I have the cube root of x squared minus 1 equals 2. Now this one's easy. This one's pretty easy. Since I have the cube root of something, to get rid of it, you're just going to raise both sides to the 3rd power. That's all you're going to do. So the cube root of this, right? So the cube root of this cubed is going to get rid of the root, right? So I'm just going to have x squared minus 1 equals 2 to the 3rd power, which is 8. Now to solve this equation, just add 1 to both sides. So you're going to get x squared equals 9. Take the square root, so you're going to get x equals plus or minus 3. Now, because this is a radical equation, I have to check my solutions. Make sure you check your solutions. I didn't have to check solutions technically for linear or quadratics because the domain of those equations are all real numbers. That's not true for a radical equation. The domain for these could be all real, but they could only be positive values. Now, because the index here is odd, the domain for this kind of radical is actually all real numbers. But if it were an even, like a square root, a fourth root, or whatever, it would have to be checked. But it's always a good habit to check this. So let me check. So -3, store in the x. So cube root. So math, there's cube root at number 4. So cube root x squared minus 1 under the radical gives me 2. Ta-da! And if you check 3 into there, you also get 2. So they both work. So my solution set is both -3 and +3. Okay, that one was pretty easy. So that's letter E. Now let's go to letter F. So 3x squared minus x plus 1 equals 0. So again, this is a quadratic equation because the highest power is squared. So check to see if you could factor it. Right? Check to see if you could factor it. So the factors of 3 are 1 times 3. The factors of 1 are 1 times 1. So I only really have 2 combinations to worry about. So I just have 2 possibilities. All right. So this is the coefficient for the x squared term. So this is x and 3x. And this is 1 and 1. And then if I swap 1 and 1, I get 1 and 1. Guess what? I have both of these are the same thing. So really all I'm caring about is one combination. They're both the same combination, so I could just get rid of one. I don't care about the other one. Once I check this, I could just, it's either going to work or it doesn't. You know, factors or it doesn't. I don't have to check both of them because they're the same thing. So, all right, I need -x, right? That's my middle term. I need -x. So when I do my outside-inside combination, I better get -x in the middle. Otherwise, it's not going to work. All right. So outside, that's going to be x. 1 times 3 is 3x. Do they add to be? How do I get them to add to be -x? Can I? No. If I add these together, I could get 4x. Or -4x, or if I subtract 1, I could get 2x, or -2x. I'm never going to get -x. So that doesn't work, which means this one doesn't work either, because it's the same thing, which means it doesn't factor. It doesn't factor. Okay. So that means I have to do completing the square or the quadratic formula. Let me do completing the square. Okay, so I'm going to bring the c term over. That's what I have. Now I'm going to divide through. My leading coefficient is 3, so I want to divide through by 3. Right? I want to divide through by 3. So I'm going to get x squared minus 1/3 x equals -1/3. All right, now I'm going to do the completing the square part. All right. So I'm going to identify my b coefficient, which is right here. You could divide that by 2, so that looks weird, but that's just going to be what? Negative 1/3 divided by 2 is negative 1/6. And then you're going to square it. Then you're going to get 1/36. You're going to add that to both sides of the equation. Add that to both sides of the equation. So, okay. What's the right side become? So negative 1/3. So negative 1/3 plus 1/36 gives me that as a fraction. That is negative 11 over 36. Okay, now remember, now that I've completed the square, right? Now that I've completed the square, this is a perfect square quadratic, right? But it has fractions in it. I don't like fractions. I want to get rid of the fractions. So what I'm going to do is the greatest the number here is 36, right? And 36 goes into 3. And it goes into it 12 times. So I'm going to multiply both sides by 36. I'm going to multiply both sides by 36. When I do that, I get 36 x squared. 36 times minus 1/3 x is minus 12x plus 1 equals negative 11. This is still a perfect square quadratic. So when I factor it, both the factors are going to be the same. Let me write that over here. So the factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. But which ones do you think I really care about? The 6 and the 6, because I know they're both going to be the same. They need to be identical. The factors of 1 are going to be 1 and 1. So, that should be a dead giveaway. Since I did completing the square, and this is a perfect square quadratic, both of these factors need to be identical. They both need to be the same. So that tells me that these two and these two should be the ones I need. So this is the coefficient for the x squared term. So this is 6x and 6x. And this is for the c term, so that's 1 and 1. Now I just need to figure out the signage. So again, 6x times 1 is 6x, right? 1 times 6x is 6x. They need to add together to be negative 12. How do I get that? They both need to be negative. All right, they both need to be negative. So that means this is negative and this is negative. And then finally, negative 1 times negative 1 is positive 1. So I know that these are the factors. So I could rewrite this as 6x minus 1 squared equals negative 11. Now just take the square root of both sides. So I'm going to get plus or minus the square root of negative 11. Now negative 11 doesn't reduce at all. You can't factor a perfect square out of here, but you could pull out a 1 or an I, right? So I'm going to have plus or minus I root 11, and that equals 6x minus 1. So add 1 to both sides. So I'm going to get 1 plus or minus I root 11. Divide both sides by 6. X equals 1 plus or minus I root 11 all over 6. So my solution set, since this is a quadratic, I don't need to check it really. My solution set are the solutions 1 plus I root 11 over 6, comma 1 minus I root 11 over 6. Those are my solutions. I mean, that was a long problem, and it was, there was a lot of fractions here. It was a little ugly, but, you could use that, you can either use completing the square or the quadratic formula. Either one will work fine. But you should know how to do completing the square. I mean, you have to know how to do completing the square. Not should. You must. Don't worry if, sometimes these problems do get a little lengthy, but sometimes they don't. It just depends on what you have. But like I said, if you can do the review sheet, I think you'll be fine for the test. I really do. If you're feeling overwhelmed or if you feel like you're not getting it, just take a deep breath, calm down, relax, and come back to it if you need to. Letter G. X to the 4th minus 5x squared plus 4 equals 0. Now, this equation, well, the highest power is to the 4th power, so that means it's a 4th power, it's a 4th degree polynomial. Now, there is no method for a 4th degree polynomial. However, this is one of those equations that are quadratic in form. It may not be quadratic in X, but it might be quadratic in something else. So remember, the rule of thumb for a quadratic in form equation is to look at the middle term, x squared. Usually you want to substitute u in for the middle term, typically. So I'm going to let u be equal to x squared. I'm just going to replace u with x squared. Or I'm sorry, I'm going to replace x squared with u. And when I do that, right, so the first term, right, if I rewrite the first term as x squared squared, right, this is something squared minus 5 times x squared plus 4 equals 0. So if I look at this as quadratic in form, right, this is something squared minus a number times something plus a number. That means this is quadratic in form, right? Something squared plus a number times something plus a number equals 0. That's a quadratic. Something squared minus a number times something plus or minus a number times something plus or minus a number plus or minus a number. So my quadratic, I'm letting u be that, right? That's what you want to see, the quadratic in form. You can see how they related, right? So I'm going to let u equal x squared. So when I do that, I'm going to have u squared, right, minus 5 times u plus 4 equals 0. Now this is quadratic in terms of u. So now I want to see if I can factor that. All right. So if I factor this, well, the leading coefficient here is 1, right? So I just need to look at the factors of 4, right? The factors of 4 are 1 and 4, and 2 and 2. All right. Which ones are going to work? So 1 and 4, 2 and 2. So this is 1, so right. So that's going to be u and u. U, and I don't need to swap them because the leading coefficient is 1. I don't need to do that. So 1 and 4, 2 and 2. Which one's going to work? So I need to get -5, right? So it looks like this one's going to work, the first one, because 4 and 1 give me 5. So u times 4 is 4u. 1 times u is u. In order for them to be -5u, they would both need to be negative, right? Because -4u plus -u is -5u. Finally, -1 times -4 is +4. So those are my factors. U minus 1, u minus 4. So now I could set each factor equal to 0. Which means u equals 1 and u equals 4. Now I'm not done because my original equation was in terms of x, not u. So now I could replace u with x squared. So now I have x squared equals 1 and x squared equals 4. Now I could solve these equations. These are, take the square root for each one, right? Take the square root here, you're going to get x equals plus or minus 1. X equals plus or minus 2. So, because this is a polynomial equation, my domain is all real numbers. So I don't really need to check. So my solution set is 4 solutions. It's going to be -2, -1, 1, and 2. Later on in the course, you'll learn that a 4th degree polynomial could have up to 4 solutions. Letter H. So this is a radical equation. This is a radical equation. So remember, in order to solve a radical equation, we need to raise this to the power of the index. This is a square root. So ultimately I want to raise it to the second power, but before I do that, I have to isolate this, right? So I have to subtract x. So that's what I have now. Now I want to square both sides. Because this is a square root, so to get rid of it, you're going to square both sides. What you get is 2x minus 3 equals 3 minus x squared. So by doing that, you get rid of the radical, but now you're going to have a polynomial. Okay, so in order to do this, you're going to have to distribute everything and combine like terms. All right, you're going to FOIL this out. 3 times 3 is 9. 3 times minus x is 3x minus 3x plus x squared. Okay, 9 minus 3x is minus 6x plus x squared. What the highest power you see here is a squared, so that means ultimately this is going to become a quadratic equation. So you're going to combine like terms, right? Subtract the 2x, add the 3, right? You want to put this in standard form. So you're going to get what? So x squared minus 6x minus 2x is minus 8x. 9 plus 3 is what? 12 equals 0. So there's my quadratic. So now this became, by doing this, it became a quadratic equation. See if you could factor it. All right. You could have 1 times 12. My leading coefficient here is 1, so I don't really care about that. 1 and 12, 2 and 6, 3 and 4. Which one of those is going to give me 8? The middle one, right? Yeah, that's going to give me x and 2, x and 6. You know, we've done this enough that you should be able to see that pretty quickly. Now, I need to get negatives, right? So that means that, you know, x times 6, that should be negative. That should be negative to be negative 8, right? So they should both be negative. And since negative 2 times negative 6 is positive 12, those are my factors. So I have x minus 2, x minus 6 equals 0, which means x minus 2 equals 0. X minus 6 equals 0, which means x equals 2. X equals 6. Now, since the original equation was a radical, I need to check my solutions. I need to do that. So when I do that, 2 store x, my original equation was the square root of 2x minus 3 plus x outside the radical. And when I hit enter, I should get 3, and I do. Okay, so 2 works. Let's try 6. 6 stored in x, retype my equation. Second enter, square root of 2x minus. Oh, I got 9. I didn't get 3. Uh-oh, so what does that mean? So that means 6 doesn't work. This worked, this one didn't. So my solution set is just 2. After all that, 2. That's the only number that works. So that was letter H. Letter I. Okay, so now with this one, again, the process still applies. You need to isolate a radical. You need to isolate a radical on either side of the equation. Now, because this one's isolated, I could just, square both sides as is. But since I'm going from left to right, I'm going to bring this one over here. It doesn't matter, but that's the way I'm going to do it. So I'm going to have this on the left equals that on the right. Now I could square both sides. Now be careful. Do not break this up. Do not write this as 2x plus 1 minus the quantity x minus 1. That's not true. You got to FOIL this out. Here this cancels out. So I have x plus 1. But I cannot break this up. I have to write this. This means I have two of these terms. There's one of them. There's the other one. I have two of them. I have to FOIL them. I have to FOIL that. Some of these radical equations can get a little lengthy, but you just take your time. This one times this one. So when you do the first product, right, 2x plus 1 times 2x plus 1, when you do that, you're going to have a squared of a radical, so they're going to cancel out. What you're going to have is this times this is going to be this. Right? But that power and the radical are going to cancel out. I'll get to that later. So this, and now times this, right? So I'm going to have, so that's going to be minus this times this, which is going to be radical. Right? Now this one, which is going to be another minus. This might look ugly at first, but it'll simplify. And then this one, that's the last. So this times this, that's positive. And that's going to be this times this, which is the same thing. So that's going to be the root of x minus 1 quantity squared. Okay. So let's simplify this. So I'm just, this is just the FOIL process term by term. All right. This is this product, outside is here, inside is here, last here. Now the first and last terms simplify a bit, right? The radical of that squared, they cancel out, so I'm left with 2x plus 1. Now, and the same thing with the last term. The radical and the squared, they cancel out, so I'm left with x minus 1. Okay, now in the middle, these are both the same terms. Like this is the same term as this, right? So that means I have two of them. So I could rewrite the middle right here. That means I could write this as negative 2 root 2x plus 1 root x minus 1. So that means I have two of them, right? I have two of these terms. Okay, so yeah, there's a big space here, but I guess I overestimated a bit. So these terms don't contain radicals in them, so I could bring them over here with the other x plus 1. Let me rewrite this as 2x plus 1 minus 2 root. Right, that's what I have. So I could subtract, well actually I can combine like terms before that. 2x and x is 3x. 1, and negative 1, they cancel out. So really all I'm left with on the right side is 3x minus this term. That's what I'm left with. So after all that, I get this. Now I can subtract the 3x from both sides. They go away. So I have x minus 3x is negative 2x plus 1 equals negative 2 times the root of 2x plus 1 times the root of x minus 1. So yeah, some of these problems could be a little lengthy. They can, but they do simplify pretty nicely once you go through it. They you know, eventually they kind of reduce down. Now sometimes when you have a radical equation, you have to, you have to square the side. You might have to do that more than once, and we do here, right? We have to do that here. Now, this is a product. This is negative 2 times this times this. This is a product. So what I'm really saying here, since this is a product, this is already isolated. I could bring the negative 2 over here if I wanted to. Right? I could do this. I could do this and then have that. I could do that, that's fine. And now because this is a product, right, I don't need to isolate this. This is already isolated. So now I have this. So now I could square both sides. All right. So this negative 2x plus 1 over negative 2 what happens there? Well, do I want to cancel that out? No, I don't want to cancel that out. I don't want to do that. So the left side becomes negative 2x plus 1 quantity squared all over 4. All right. And the right side becomes what? So now this is a product here. This is this times this. So because this is a product, I can break this up. I could write this as this times this. I could do that because this is a product. I couldn't do it up here because this was subtraction. So, this is going to simplify nicely now. So this with the square, that's going to be 2x plus 1 times x minus 1 because the radicals go away in both of them. And that's going to be equal to that's going to be equal to this. All right, because then this squared means I have negative 2x plus 1 quantity squared. And if I, negative 2 squared means I have positive 4. If I just broke that power into the top and bottom. All right, so this is the equation I have now. The radicals are gone. So now I can FOIL, distribute, whatever. I could do all that stuff. So I'm going to multiply both sides by 4. I could have kept the 4 over here, and some of you might do that. That's okay. But now it's just a matter of foiling this all out and combining like terms. So when you FOIL this out, right, you're going to get 4x squared minus 2x minus 2x plus 1 equals 4 times, I'm going to FOIL this out and then distribute the 4. So 2x times x is 2x squared. 2x times 1 is negative 2x plus x minus 1. Minus 2x plus x is minus x minus 1. 4x squared minus 4x plus 1. Distribute the 4 over here. So you're going to get 8x squared minus 4x minus 4. We're almost done. So I want to bring everything to one side here, right? And well, if you notice, if I add 4x to both sides, the 4x's cancel. Boom, 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 boom. So I left with 4x squared plus 1 equals 8x squared minus 4. So I could subtract 4x from here and add 4 to both sides, or I could do the other way around, whatever you want. They cancel. They cancel. So I'm left with what? This is going to be 8x squared minus 4x squared is what? 4x squared equals 1 plus 4 is 5. And then divide both sides by 4. X squared equals 5/4. Take the square root of both sides. That's going to be plus or minus square root of 5 over 2, because when you take the square root of 4, it's going to be 2. So that's what I got. That's a long problem. You know, it's a long problem. That's no joke. Some of these problems get a bit long, but if you could do this problem, you'll be fine. I'm not saying there will be a problem like this on your test. This is just a way for you to review for your test. But, you know, welcome to college algebra. So, square root of 5, let's check it. Square root of 5 divided by 2. Store that into x. Let me type in the original equation. Second root x plus 1 plus second root x minus 1 gives me that. And then the right side, second root 2x plus 1 gives me that. That's the same value. That means what? That means the square root of 5 over 2 works. Let me try the other one. So negative square root of 5 divided by 2. Let me store that into x. And let me type in the original equation. So that's the left side. It doesn't give me anything. Wah, wah, error message. So that means only This means I have negative 5 root 2. These are my solutions. This one didn't work. This one did work. All right. So my solution set is square root of 5 over 2. Ta-da! So yeah, that one was that one was a little challenging. I'm not gonna lie, but if you're able to do that one, you should be fine. You should be fine. These problems can get a little lengthy, but that's how you do it. So J. Okay, this is another quadratic and form equation. This is another quadratic and form equation. So you're going to have something to the second power minus 7 times something minus 8 equals 0. Something squared minus a number times something minus 8 equals 0. That looks like it's quadratic in form, right? So what am I going to put here if I have x to the negative 6? I'm going to have x to the negative third power, right? Because negative 3 times 2 is negative 6, right? Then I have x to the negative third power and the second something. So that means, this implies that u should be x to the negative third power. Let u be equal to x to the negative third power. So when I make that substitution, I'm going to have u squared minus 7u minus 8 equals 0. Factor it. Which factors of 8 give me 7? So I have 1 times 8, 2 times 4. Well, that should be pretty obvious that 1 and 8 give me 7, right? So u, 1, 8. So this needs to be negative, right? So the outside, inside. So the outside should be negative, right? Because the negative 8u, right? This would be negative 8u. Write it here. And then this should be positive, because that would be positive u. That gives me negative 7u, which is what I need. 1 times negative 8 is negative 8. So these are my factors. So that means that's equal to 0, and that's equal to 0. U equals negative 1, u equals positive 8. But I got to replace u with x to the negative third power. So how do I solve that equation? How do I solve that equation? Well, whenever you have a negative power, that just means you take the reciprocal. You could write it like this, right? That's a property of exponents that you learned in Math 105. When you have a negative power, you can just make the reciprocal and make it positive. So how do you solve these equations? Well, you can multiply both sides by x cubed, right? So if you do that, you're going to get, so if I multiply the left side by x cubed, I'm going to get 1 equals, and if I multiply this by x cubed by negative 1, I'm going to get negative x cubed. All right? Now, let me bring the negative over here. All right? You know, you could also look at this as just by reciprocating this, just flipping that. Either way, it looks fine. So you can multiply both sides by negative 1 here. So you're going to get x cubed equals negative 1. Take the cube root. So when I take the cube root of negative 1, you can do it on my calculator, right? Math, cube root, negative 1, you get negative 1. And you just take the cube root of this. That's what you do. Here, do the same thing. Multiply both sides by x cubed. Or you can reciprocate both sides. Either way is fine. So you're going to get 8x cubed equals 1. Divide both sides by 8. So you're going to get x cubed equals 1/8. Take the cube root of both sides. So you're going to get x equals, so when you take the cube root of 1/8, so math you're going to get 0.5, which is a half. So because this is a this isn't polynomial, you should check your solutions here because there's negative exponents in it. So check your solutions. So negative 1, store in x, and then type in your original equation. So x caret to the negative 6 power minus 7 caret, or wait, sorry. Minus 7x caret negative 3rd power minus 8. I got 0. Hey, that's what I had. So that means negative 1 works. Let me try 1/2. So 1 divided by 2, store that in the x. And then let me type in the original equation. So, enter. I got 0 again. Hey! So they both work. Okay. So that means my solution set negative 1 and a half. Okay. Let's look at letter K. So this is an absolute value equation. So to solve this, you need to isolate the absolute value, just like you would isolate the radical, right? So let me subtract 2. Equals 7. Now that this is isolated, you could break this down to 2 equations by dropping the absolute value. Alright, that's your first equation. And your second equation is that. Sorry, you make this equal to 7, and then you make it equal to negative 7. Now just solve each equation separately. So subtract 2 from both sides to get negative 3x equals 5. Divide by negative 3, x equals negative 5/3. Or subtract 2 from both sides. I'm going to get negative 9 on the right. Divide by negative 3. X equals positive 3 on the right. On the right one. So check your solutions. Negative 5/3. Store that into x. Now type in the original equation. So if you go to math, number, absolute value is the first thing you see. 2 minus 3x plus 2. You should get 9. You do. Let me try 3. Type in the original equation. Second, enter. Second, enter. I also get 9. Good. That means both of them work. So my solution set is negative 5/3, comma 3. You know, absolute value equations are relatively straightforward. Letter L. Okay, now with this equation, this is a 4-term polynomial equation. So you want to see if you could factor it, right? You want to be able to factor it. Now there's no GCF here, right? There's no GCF. 2, 5, 8, and 20 don't have anything in common. So I could factor this by grouping, right? So that means I can factor a GCF out of the first group and the second group. So what is the GCF in the first group? It's going to be x squared. The GCF in the second group is going to be negative, because the leading term here will be negative. It's going to be negative what? The highest number that goes into 8 and 20 is going to be 4, right? So that means GCF in the second group is negative 4, okay. So now if I factor x squared out of the first group, minus 4 factored out of the second group, so when I factor that out of the first one, I have 2 plus what? Oh wait, not 2, 2x plus 5, right? And then if I factor a 4 out of the second group, right, 4 out of negative x is 2x, and negative 4 factored out of negative 20 is positive 5. So now if you look here, right, they have a common term of 2x plus 5, the whole thing. So my GCF for the whole polynomial is 2x plus 5. So if I factor that out of the first group, what's missing is the x squared. If I factor that out of this group, I have minus 4. So that's factored by grouping. Now I'm not quite done. This term doesn't factor. That's linear. This is a difference of two squares. So this still factors. This factors to be x plus 2, x minus 2. Now I'm done factoring, so I could set each factor equal to 0. Solve for x in each factor, so just subtract 5 here. Divide by 2. X is negative 5 halves. Subtract 2. And 2. So those are my various solutions. Again, I don't need to check these because this is a polynomial equation. Those are my solutions. Okay. Let me do letter M, and then that'll be it for the part 1 of this video. Part 2 will be the rest of the sheet. Number 1 was a long problem, wasn't it? A lot of different things, but you know, the rest of the sheet shouldn't be too long. So letter M is a rational equation. So when you're solving a rational equation, you want to make sure it's completely factored, right? So you want to factor the denominator here. So the denominator is a quadratic, so you want to factor that. All right. So the factors of 2 are 1 and 2, right? You need the one that's going to give you a positive 1, so we want to make sure this one's positive and this one's negative. Okay, so my denominator here is x minus 1, my denominator here is x plus 2, and my denominator here is x minus 1 and x plus 2. So what is my GCF? Or I'm sorry, not the GCF, the least common denominator, sorry. I have factoring on the brain. What's my LCD here? The least common denominator is all the factors you see in all the denominators. So I have an x minus 1 and an x minus 1. I have an x plus 2 and I have an x plus 2. I don't see any other different factors in the denominators, so that's it. Okay. So now that that's my LCD, I'm going to multiply both sides of the equation by the LCD. I'm putting brackets here to indicate the equation. That's the left side. Equals, multiply this by the right side. Alright, so that's what I have now. Okay. So when I distribute the LCD, the fraction should, the denominator should cancel out. So when I distribute this to the first term, the x minus 1's cancel. So I'm left with 1 times x plus 2. In other words, I'm just left with x plus 2. When I distribute this to the second term, the x plus 2's cancel. So I'm left with plus 3 times x minus 1. equals, now when I multiply this by this, both the x minus 1 and x plus 2 cancel. So I'm just left with 11. Now this is a nice linear equation. Distribute the 3. X plus 3x is 4x. 2 minus 3 is negative 1. Equals 11. Add 1 to both sides. So you get 4x equals 12. Divide by 4. X equals 3. Now, remember, when you're doing a rational equation, you want to make sure that this value you get isn't an extraneous solution, right? My extraneous solutions here are values that give me division by 0. 1 gives me division by 0. Negative 2 gives me division by 0. And in the other one, either 1 or negative 2 give me division by 0. So the only extraneous solutions here I have are 1 and negative 2. Since I got 3, I'm fine. So my solution set is 3. Okay, so that's all the equations in number 1. What I'm going to do now, so that's part 1 of the video. In part 2, I will do questions 2, 3, 4, 5, 6, 7. We'll go from there. But that part 1 is all the different equations in number 1. So that's the end of the video for part number 1 of the review sheet for the exam 1.